Okay, lesson 3.5, we're going to learn how to graph basically the square root function and the cube root function. We're going to pay close attention to their domain and range as well. And I'll do part 1 right now, and then I'll make another video for part 2. That should get us through the study guide. And then tomorrow we'll work on the homework assignment. So that's my plan. So graphing square root and cube root functions. Basically, here's the picture of both functions. This basic way of looking at the square root right here is what we call the parent function. And then there's all sorts of ways to stretch these functions and compress them and translate them. So some of the things we might want to pay attention to here is like the domain. What is the domain? Well, you can't put negative square roots in, or negative numbers into a square root, so that would make the domain of x greater than 0. But also note that the graph of the function, never goes down into the negative y portion. So this graph also has what we call a range, which is talking about the y values. And in this case, the range is all this stuff this point on up this way. So there's a range also, y greater than 0. And so on some of these problems, we're going to start talking about the domain and the range. If we look at this other function, the cube root, this is what we call the parent function for that one. And notice these 3 points. Those are pretty easy to get. That's when we plug in 1 or negative 1. And since you could put negatives in cube root, the domain for the cube root function is all real numbers. And that is the case with the range as well. Now, it may look like for a moment that there's some sort of asymptote coming across here. Turns out for the cube root function, there is no asymptote. This thing just goes up and up and up, and it just goes up real slow. But as you go out to infinity on this axis, whoops, that was awful looking. As you go out to infinity on that axis, this eventually goes up, 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 and goes to positive infinity that way. It's just going out to infinity a whole lot faster this way than it is going up that way. So anyhow, the domain and the range for this one is all real numbers. So you could have negatives, you could have positives, you could have 0. Cube root of 0 is 0. And so we're going to graph a couple of these, and I'm going to show you a method to use, or some ideas anyways. So on all these problems, at least in the beginning part of the assignment, you'll graph the parent function, and then you'll also graph this one next to it, and just basically compare it. Like you'll notice the key difference here on this problem is that there's a negative 2 here, and this one doesn't have a negative 2. So the parent function is the plain function all by itself. And then what does this cause? Well, that's part of what we want to be able to do is just get a general idea of what causes what to graph. And so to graph these, basically what we want to do is make a t-bar like this, and make a t-bar, put x's here and y's here. And if you want, you could create a second one for this other function. So this one will do the square root of x. This one will do negative 2 times the square root of x. Okay. And so all we need to do is pick some values. Now, here's what I want to recommend. When you're doing square roots, you may as well pick x's that are perfect squares, because it's easy to do a square root. So like for example, we know that 1 squared is equal to 1. We know 2 squared is equal to 4. We know 3 squared is equal to 9. And 4 squared is equal to 16, and so on. So the choices for my numbers might be 0, 1, I think what I'll do is choose 4 and then 9. Because when I put 0 in here, the square root of 0, of course, is 0. When I put 1 in here, the square root of 1 is 1. And when I put 4 in here, well, the square root of 4 is 2. And the square root of 9 is 3. So, if you want, you can put in other numbers too. I mean, if you want to put 5, it's just those aren't perfect squares, so you have to just put them in your calculator and find out the decimal equivalent, which is not a problem. You can do that too. But anyhow, if we graph the parent function, we have a point here at 0, 0. We have a point here at 1, 1. Then we have 4, 2. Then we have a point 9, 9 would be somewhere around here, 9, 3. So the square root function comes this way. And just as we said before, the domain for this one and the range, those are some of the things we should answer. Erase this now. And so the domain for this one, we're going to say x is greater than or equal to 0. And the range, we're going to say y is greater than or equal to 0. Okay, so for this function here that we're doing, we'll basically use the same numbers because, like I said, these are easy square roots to do. So I would use 0, 1, 4, and 9. And we found out what the y values are for this portion. All we basically need to do is take these numbers and multiply it by -2. So if you take 0 and put it in here, you get 0, of course. And 0 times -2 is still 0. If you put 1 in here, you get square root of 1, which is 1. But this time you multiply it by -2, so we get -2, -2. And if you put 4 in here, well, we get square root of 4, which is 2, multiplied by -2, we get -4. And finally, if we put 9 in here, we get square root of 9, which is 3, multiplied by -2, we get -6. So I think what I'll do is I'll plot this in another color. 0, 0 is the same point we had before. At x equals 1, we're at -2. At 4, 1, 2, 3, 4, we're down at -4. And as we plot some more points here, at 9, we're at -6. So right about there. So we have our curve like that. And so the domain and the range is going to be the same as these. Same numbers. We can't have, oh, now hold up here, just a second here. The range is different now for this function because now the range is underneath the x-axis. So the range would be y is less than or equal to 0. Now this equals 0 there, but now the graph is down, it's down here only. So the range for this function is here. Now, if you take a look at the two graphs, we're asked to compare things. And so naturally you could say, well, the parent function was above the x-axis, and this new function is below. And you can say, well, what part of it contributed? And I think most people would say, well, the negative right here contributes to that. And it causes the parent function to be reflected across the x-axis. So this one's like flipped. But if that were the only case, it would be flipped to be right about here. And what we see is that this has been stretched down the vertical axis. And so there's not only a reflection, there's also a stretch in the vertical direction. And that's what they mean by compare. You compare the graphs. So we would say we would say this graph is well, we would say like number 1, reflected across, so this way a little bit, reflected across x-axis, axis. And number 2, we could say it's been vertical, there's a vertical stretch. And we could say in the direction, we could say like downward. Okay, so that's what's meant by domain and range. It's also what's meant by comparing the graphs. And so you'll put both graphs on a single plot, and that's all there is to these problems. Let's try a cubic one now. Same idea. We're going to graph the parent function, and we're going to graph the new function right on the same set of axes. So we're going to put xy again, and xy here. And this, of course, will be the parent function. So we're going to have the cube root of x. And over here, we're going to have 3 halves times the cube root of x. Well, so now this time, we probably want to choose numbers that are perfect cubes. And so, let's just review that real quick. 1 cubed, of course, is equal to 1. 2 cubed is equal to 8. 3 cubed is equal to 27. Now keep in mind, we are allowed to put negative numbers in here. So in this case, what I think I'll do is I'll put 0 because that's going to be easy. I think I'll put 1. I think I'll put negative 1. And then I'll put negative 8 and positive 8. Because those will be easy. It's easy to do these cube roots. Now once again, if you want to pick some other numbers, that's fine. Just put them in your calculator and find the decimal equivalent. I just think these are easy. So if we put 0 into here, of course the cube root of 0 is 0. If you put 1 in here, the cube root of 1 is 1. And interestingly, the cube root of negative 1, let's look at that one real quick. The cube root of negative 1. Well, keep in mind, you can write this as negative 1 cubed. And then you're taking the cube root. And why is that? Well, negative 1 times negative 1 times negative 1 is equal to negative 1. Well, and so we get negative 1 here, and then we just continue. The cube root of negative 8, well, that's equal to negative 2 times negative 2 times negative 2. So the cube root of this is going to be negative 2. And the cube root of 8 is positive 2. So let's plot these points and see what our parent function looks like. Well, we have a 0 here, a 1 here, and at negative 1 we have this point here, and then at negative 8, that would be this point right about here. We're down to negative 2. And going in this direction, if we went to 8, we would be at positive 2, so right about there. So this curve, we saw it before, but there's our parent function. It kind of curves in this way, and then kind of does that. Okay, so there's our parent. Now, to do this function, we'll just go ahead and plug in the same exact x values. We've already calculated what they're going to be. They're going to be these numbers right here. So let's just take a look. After you take the cube root of 0 here, you would get 0 and then multiply by 3 halves. Well, that would give us 0. And in this case, if we took the cube root of 1, we'd get 1 and then multiply it by 3 halves. So that would be 3 halves. Okay. And if you did the negative 1, well, the only difference would be that this would be negative 1 once you take the cube root, and then you multiply by 3 halves, well, that would make it negative 3 halves. And if you put in negative 8, well, we get the cube root of negative 8, which is negative 2. And so if you have 3 halves, oh, that's an awful looking 3, and multiply it by negative 2, in this case, the negative 2 cancels off here. Well, the negative doesn't, so you just end up with negative 3. And the same sort of thing happens when you put the 8 in, you get the cube root of 8, which is 2. The 2 cancels off with its denominator, so it gives you a positive 3. Well, so let's see, this point is in common. When we're at 1, we should do 1.5. Negative 1, we're at 1.5, kind of here. And then at 8, we're at negative 3 down here. And on the opposite side, we're at positive 3. So this, once again, has the effect of doing a stretch. So it's like the parent function is being stretched up the y-axis a little bit. And it's being stretched down the y-axis. So once again, we want to talk about the domain and the range. And the domain and the range for both of these functions would be domain. We're going to write it this way. X is equal to all real numbers. And how do you know that? Well, because you could put in negative numbers, you could put in 0, you could put positive numbers. So there's no need to put a restriction here. And that's true for both functions, both of these. The range, well, y is also equal to all real numbers. And so we can write it like that. So once again, there are some y values here. Well, these are the negative ones. There's 0. These are the positive ones. So the domain and the range are the same, basically. X and y could be equal to all real numbers. And then to compare, we'd say, okay, that we would say vertical stretch, okay. And since there's no negative, there's no reflection this time. I mean, this graph is basically the same as this one. It's just being stretched in the y direction. Vertical stretch. Okay, so that should help you get through the first 4 problems on the study guide. So this is where I'm going to stop for now. And for homework, I'll show you how to do some translations. And then you'll do the last 2 problems on the study guide.